Hello Calc, how you all doing? You're reviewing this if you need extra help on the assignment, and I promised to do a couple problems, so I'm going to do two problems, and you can view this or not. So if you are viewing it, it'll be sometime during our break from 4:07 to 4:18. So let's see what's up for today. I'm going to do the homework one, number 13b. And I am going to recognize that that took the area enclosed by y equals x squared and y equals 4x minus x squared. And it's going to take the area enclosed by those two graphs and revolve it around the line y equals 6. So that will create a solid of which we will find the volume. Alright, so a quick sketch to see what this looks like. So, let's see how much light we need here. Let's say this graph, I know this is the smiler. This one, if I was on a situation where I couldn't use a calculator, I would do a quick table and see that I know it's a parabola opening downward, and I think I can see that this value is on it, and there's lots of ways you could get it, but quickest way is on the calculator. And we are looking at this area enclosed by these two graphs, and it's going to be revolved around y equals 6. So it'd be helpful to know what that point was. And this point I can see is 0, 0. So I'm going to set these two equations equal and see what shakes out. X squared is the one equation, 4x minus x squared is the other. Move the x squared over where it becomes 2x squared, and the 4x over, and set it equal to 0. Solve that by factoring. So I see that x equals 0 or 2. So I can tell back over here that this point is at x equals 0 and this one is at x equals 2. Alright, now I am going to revolve. It'd be helpful to know how high this is. So if I put 2 into either of these equations, the simpler being the y equals x squared equation, I get y equals 2 squared or 4. So I know the name of this point is 2, 4. Now it helps me get a good picture of revolving this around y equals 6. Well, here's y equals 4. So 5, 6 right there. So here's the graph of y equals 6. So I'm going to spin this around so this will appear up here equidistant as it is below. It will be above. So something like this. And this is forming a solid, so it's sort of a weird straight shaped bowl, I suppose. So it'll look pretty normal on the outside. Inside, the bowl's interior will have a unusual shape. Alright, so with that, I am going to check something that's on the stove while you draw a typical disc, not the one at the ends, but one somewhere in the middle, and sketch the radii, and I'll be right back. Alright, did you draw in the disc? Alright, I'll say this one. It can be any typical, I said disc, but it's really a washer because it has a hole in the middle. So there is the outer disk, the inner one, and we found that washers, the volume of just this one disk, which is hooked to the function right there and right there. I always draw the points because somehow this outer and inner disk are hooked to a function or a line somewhere. So there's my points of interest here and here where they hook. So I am going to find the volume of this, we call it a washer. And I do that by doing the integral of pi times, these are going to stack up across from here all the way across. So this is going from x equals 0 to x equals 2. And then I'm going to do outer radius squared minus inner radius squared. And is this a dx or a dy problem? Well, I used the test of the thumbs. The thickness is right there, and that's red on this axis. The distance between my two thumbs is a change in x, infinitesimally small. So I'm going to indicate that. Alright, so now I will, not sure how much color shows up on here, but I'm going to indicate in red the outer radius. So a little bit, anyway, it should. So the outer radius, I have a choice of drawing the radius up or down, but I'm going to go down where my function is instead of that reflection up there. I'm going to go for the outer radius, it's going to go from here to here. So it's going to go from that line I revolved it around to the outer part of the solid enclosed, the area enclosed by the two graphs. So this is the outer point. Notice to get to that point, I went over x and up y. And which y value is it? It's the smiler. So it's this one. So it's the y equals x squared one. So now I am going to represent that disk, or that distance. This is the radius. It's from here to here. It's getting close and it's hard to see. So I was trying to add some color. It's not very clear. Let me see. Trying to add some color here. Stabilize this for a second. The red is from here to here. From here to here, and I'm trying to show you with this brace. So what can I call that? Well, I notice that this line y equals 6 goes from here to here, and this point, which is involved, goes from here to here. So do you see that this thickened red spot, this thickened red radius is y minus this distance, which is, remember, I went over x and up y. So, alright, so I'm going to call it that. So we have, we have now the outer distance. So the outer one was the value 6 minus the y value of, I'll call that the first graph, and this the second, so we don't get the two y's mixed up. So I'll call that y sub 1. It is the smiler I'm talking about there. So that's the outer radius squared minus the inner radius. Alright. The inner radius. Let's work on that now. Alright, the inner radius is going to go from here to here. That amount. And that value I can represent in a similar way, because from here to here, again, is a value of 6, but this value is related to this point, which I highlighted. It's kind of disappeared in the morass, but I went over x and up y on this function. So that value is y. We called it y sub 2. So if I call this y sub 1, this will be y sub 2. So I went over x up y sub 2. So this value is y sub 2. This value is 6, and I want the green value. So I think you can see now that it's going to be 6 minus y sub 2. And again, these are dx. Since we're working in dx, we got to switch our y's to x's. So the y1 was x squared, and the y2 was, what was it, 4x minus x squared. Alright, so a little slop never hurt anybody. Before I would stop and put that in my calculator, I would simplify this whole thing. So I'd square this binomial. I would combine this, this is a trinomial that's squared. So you can see over here I did all that legwork. I did this trinomial times this, and everything kind of canceled out when I squared this binomial and then squared this trinomial and subtracted it from the square of the binomial. Here's what was left. So I'm sort of like our answer key. I'll show you my work, but I won't talk you through it. At the very end, here's all that was left. 8x cubed minus 40x squared plus 48x. And I noticed they all had a 8 in them. So I pulled out an 8 along with my pi to make the integral even simpler. And I asked you to do at least one integral by hand, so if you get this one down to this, it's a pretty easy one to do by hand. And when I got x to the 4th over 4, 5x to the 3rd over 3, 6x squared over 2, and put in the 2 in those spots and the 0 part zeroed out, I ended up with 64 over 3 pi once I multiplied the 8 pi through. So I'll show you my work, but again I'm not going to talk you through it. So in case you're trying to do it by hand as well, you can see if you agree with me. Alright, when I squared 6 minus x squared, I got this. And when I distributed the negative sign before I squared this trinomial, so I had to multiply 6 minus 4x plus x squared times itself. So all those terms, let's zoom out so maybe I can get them in one shot. Yes, and a lot of them cancel each other out. And it left me this expression. So then I grabbed this expression and those expressions, and since they were subtracted, I changed all the signs, and it came down to what I have said already. So there's the legwork if you want to see it. Alright, I'm more interested in the setup and the calculus, so I'm okay if you get to a point where you're comfortable putting it in the calculator, you can do that. So it would have to be, this would be the earliest spot you could do that, because we have to have it all in this variable. And if you didn't simplify this and put this in the calculator, you should get it right, even though you have to mess with a lot of parentheses. So be careful. It should get you to this. So again, it'll come out to a decimal. If you divide that decimal by pi and change it to a fraction, you should get right to this form, which is what you need. Alright, so that's one example. I'll do the other on part 2.